Okay, so I'm not going to be showing the presentation. I just want to tell the overall story of what we want to do and how it connects with Cardano. The idea of the Universal Chemical Library is to integrate the knowledge that we have about chemistry on a digital platform. And we are all dependent on chemistry in everything from our energy systems to how our bodies function to the biology, to everything. But the problems that we have in the chemical industry and in chemical research, including molecular biology, molecular genetics, they are that the field itself is very conservative and the education of chemistry is very conservative as well. So even though we had huge changes in such areas as the computers and the internet over the past 50 years, if we look at what happened in how we learn and how we apply chemical knowledge, there haven't been all that many changes. So it's a field, the chemical research and engineering, it's a field which I think can be upgraded very significantly with digital. And the problem becomes how exactly to do that, because with chemistry, well, obviously there are online publications on chemistry. There are ways to share your data. But what we are trying to do with the project, with NanoLab and with Universal Chemical Library, is to actually not just give people existing tools like websites, wikis, data processing applications, but to see what digital can offer to change research completely. That, in our view, is to use virtual reality to allow people to interact with the atomic and molecular world directly, and that's one part of our project. And the second part of the project is to basically create a library of all the different molecules, compounds, and objects that chemists work with, and move them into a distributed database so that whatever knowledge we have about a particular molecule, be it a medical or an industrial application, we would have all the connections to different types of applications, different challenges, including research projects that need to happen, and so on. And there is, it's a little bit difficult to tell what kind of like category that is, because there's nothing like that in the field of chemical research and engineering at the moment. It's all very traditional. And when people think about what kind of images they have about chemistry, it's that people in a lab with flasks and wearing white clothes, and then mixing something to change molecules. But to change the approach that people have, so that what chemical students and chemical researchers and chemical engineers would do is they would reality where there are atoms that they can structure in different ways, where there are this infinite variety of objects, which are digital objects in their VR, but which correspond to actual molecules, compounds, macromolecular objects, etc. And they would be able to work there, interact with each other, and so on. And for that, we have proposed this project. And the reason we think it needs to happen on Cardano, there are two reasons. One is technical. We need a distributed Web3 platform on which we can build this essentially a big database of all the chemical objects. And the second is related to the innovation infrastructure. And the second one is actually more interesting, because what's happening now over the past few years with initiatives such as Project Catalyst is that part of the society which stands behind different Web3 projects, they are essentially trying to take the power from existing research funding and society managing institutions, and try to change the priorities. Because what we are doing here right now, we're here in the Konma Pitch Ground for Project Catalyst of Cardano, we are essentially claiming to be able to replace the mainstream institutions that have been funding science and engineering for the past half a century or past century, and trying to compete with governments, saying that in certain areas we can do a better job than they have been doing. And that's a principle which we want to use for the Nanolab and Universal Chemical Library projects as well. We want to take some of the work that researchers and engineers are doing in chemistry and move that to a different platform where there is it's not just about more control and more transparency, but hopefully about more efficiency, about what can be done. And there are many examples where existing system doesn't work, and I'll just share one of them. If you've been following the story of vaccines against COVID, you would know that the basic discoveries about mRNA, which allowed rapid creation of vaccines, were done by a maverick scientist, a woman from Europe, who came to the United States, and she was denied most of the opportunities to work, and nobody was interested in what she has been doing. But then after COVID came, it turned out that her work was actually incredibly relevant, but it wasn't supported by the big institutions for about a decade. So I want those stories to become stories of the past, and I want change to happen in chemistry, especially because when we look into the future, there are a huge chemical challenges, including what we need to do with CO2 and so on. So that's about what we want to do. Thank you.
Thank you so much for that, Anila. So, I mean, as you mentioned, it does really make sense, the fact that chemistry being at the fundamentals of everything. So, this is something entirely different, and it's a very new look at how this can work with Catalyst. I'm really excited to have you here. Chemistry is not my best knowledgeable topic, so I am going to open up the room for anyone else. I think George might like to take a peek at this. If not, if anyone has any question with Daniela, please do.
Yeah, thanks, Angit. Thanks, Daniela. A good project, good presentation, and as we discussed in the previous one too, the community of reputation, it takes time. Even with the vaccine, we hear the story you are saying is a very good highlighting moment to say the dev work can, if not properly supported, it takes even longer unless there is a critical moment to push that forward. So yeah, great work, and look forward to see you more in the Cardano and the crypto community to enable this decentralizing movement, to enable the modern research and with reputation, just like open source DAO too. Like maybe there are efforts where it can come together between the science research and the work you are doing in publications and the chemical research. Yeah, congratulations. And
Thank you.
Hey, Danielle. I have a question. Anybody else? And so when can I go into this chemical metaverse? I think that would be really, really incredible, because the point being is that it's not science and chemistry isn't necessarily about lab coats and flasks and Bunsen burners. There's a lot that you can discover in this sort of community backyard setting, and that's what I get excited about. And then, with all of these incredible supercomputers and AIs and new technologies and worldwide networks and access and like what we can do with that type of stuff. Is that what this is sort of focused on, or and then how far along on your roadmap are you?
Well, this is exactly what we are focused on as midterm and long-term goals. The first step is to actually open the door, and we've kind of done that already. Like, we have a VR application which runs on Oculus Quest 2, where people can basically with their hands build molecules, and there are some chemical algorithms which are already like running in the application to simulate what happens in real time, in pseudo real time. Of course, it's accelerated when it happens in the real world, and slowed down when it happens in VR, because the difference is a billion times. But it's pseudo real time, and you're right calling it a metaverse, because there is essentially not just opening a file and working with one molecule and then like exiting. It's really about building systems and about understanding systems. And it's it's difficult because you have to change really what people believe about what chemistry is, because even in schools they're forcing this view that, okay, now first you sit in a class and you listen to a teacher, and then you go into a lab and you stand with the in this 19th century chemical setting. But what happens in real science, even when you think about how DNA was discovered, it was really a question of structure. It was a matter of Watson and Crick trying to build models of how the DNA molecule can be structured in 3D. And so what we're doing is we're already trying to give this sort of capability. And in our roadmap, we currently are at the stage where we have the existing prototype application which works and which anyone can set up manually on their Oculus 2 Quest virtual reality helmet. And the next stage is to just finish the release version so that we can open it publicly. And then we would be able to reach out to more people with the this chemical library aspect, like creating these databases, connecting them to existing sources of data, and then allowing to explore any type of molecular structure in VR interactively.
That's fantastic. Thank you so much. Yeah, that's wonderful.
Thank you.
Yeah. One more question, Danilo. Like, do you have actual participation with universities or schools now? Like, what is your strategy for enabling?
Every time we approached or met people from schools or other educational institutions anywhere, they were interested, and we have been doing pilot tests, but because the application is like 90% finished, it's not 100% finished for the use in schools. We couldn't move beyond the pilot projects, beyond the demonstrations. But even if it doesn't work out with schools because of bureaucracy and because of various requirements, we can always work directly with students simply through the platforms of Steam, Oculus Store, and other markets for VR applications where they would be able to just download it. And of course, eventually we will also have some entry-level apps that work with in 2 dimensions on any like tablet or computer. But for interactive work, of course, they need to get into this metaverse-like environment. And here we depend on which schools want to be using some high-tech solutions. Those that want, they are more interested in using VR, in using some digital platforms, and we will work with them, and everyone else will either follow or fall behind. That's up to them.
Thank you.
Thank you so much, Danila.
Hey,
Yeah.
last question. By the way, I love the story of the scientist that was denied everything and then played a critical role in COVID vaccine. I think that's small things. The small details matter. I'm pretty sure it wasn't so small for her. But as always, what is the PA feedback that you guys have gotten so far?
Hey, Danila.
Second.
Yeah, I think you just
Okay.
lost signal.
Yeah. Danila, I ask, what is the PA feedback that you guys have received so far?
Feedback.
From the proposal assessors.
I like most of it. There were many questions about specific implementation details. I went through the assessments like I think 3 days ago, so maybe there were some changes that I haven't yet seen. But I agree with most of the. I mean, we don't have the time right now to go through all of them, of course, but I think most have been quality comments, and we definitely would use some of the suggestions, and we have answers to some of the others. But in general, I liked this, and also, like, I have to compliment the overall system of Project Catalyst, because it's so much better than what you have when you apply with your project to some like government grant awarding organization, where you would get almost zero feedback, and if there is any feedback, it's completely crazy. Like one time we were told that our project was going against the laws of nature, because there apparently have been a category somewhere in the evaluation forms, and they marked that it's against the laws of nature. And we've been just doing some like computer programming. What is against the laws of nature? It's not magic. It's not pseudoscience. But here it has been very fruitful. So I applaud that.